Let us begin by reading aloud the word problem given. Evelyn found 63 pieces of candy under the couch cushion. 6 of these candies are lollipops. How many candies are not lollipops? Now, the first step in our strategy for problem solving has always been to analyze the problem. That is, read the word problem as many times as necessary in order to extract the right amount of information that you need to assign a variable and form an equation. Now, when talking about assigning a variable, usually the assignment of the variable lies in the question being asked. In this case, the question is, how many candies are not lollipops? Now, one of the key words here is going to be the word not. That's going to be very crucial in our assigning of the variable. Okay, so now that we know what it is exactly that we want to find, we now know what our variable is going to represent. Again, we could use any letter in the alphabet. We'll go ahead and use X. Let me go ahead and color code that to match our blue. So now X is going to equal the number of candies that are, and now this is where the color comes in, not lollipops. Okay, so here we go. So again, we have now assigned a variable, and we're going to assign that variable to be the letter X. And next is going to represent the number of candies. Can't spell here. Let me go ahead and fix that typo. So X is going to represent the number of candies that are not lollipops. And then again, your assignment of the variable comes directly from the question being asked. Notice the question is how many candies are not lollipops, and how our variable represents the number of candies that are not lollipops. Very similar. Again, it's simply the question reworded in the form of a statement. So now that we have assigned the variable, let's go ahead and continue analyzing the word problem. Now we know Evelyn found 63 pieces of candy under the couch cushion. We also know that 6 of these candies are lollipops. So let's talk about it. So there's 63 pieces total, and 6 of these are lollipops. So the 63 pieces of candy is equal to the sum of the lollipops and the candies that are not lollipops. So let me go ahead and state that in a sentence. So here we go. So the total number of candies equals the number of lollipops plus let me go ahead and color code this, non-lollipops. Okay. And then again, keep in mind that what it is we want to find is the number of non-lollipops. So maybe I can even color code that a little bit better. We could do a little bit better than that. Non-lollipops, let's go ahead and make that blue. So here we go. Non-lollipops. There we go. Okay, now it matches up. So again, we're going to form an equation, and that equation is going to be the total number of candies equals the lollipops plus non-lollipops. So in this case, the 63 pieces of candy, you're either going to be a lollipop or you're not. And the good thing is that we know these actual numbers that we could substitute in for. So let's go ahead and do so. So let's see, let's create our equation. So there's going to be the equal sign. Now the total number of candies, we know that to be 63. And that's going to be equal to the number of lollipops plus the number of non-lollipops. Well, how many lollipops are there? We know there's 6. And how many non-lollipops are there? We don't know. That's exactly what we want to find out. But we actually know it represents the variable x because that's what we assigned the variable to be. So that's going to be our equation. So let's go ahead and solve this equation. Whenever you solve an equation, again, always start with the original equation found in step 3. So 63 equals 6 plus x. Plus x. Now what we want to do here is we want to isolate the variable x. That is, we want to get it by itself. The x is on the right hand side of the equal sign along with the 6. So right now we are adding 6 to x. So in order to isolate the variable x, we want to get rid of that 6. Since we're adding 6, we want to do the opposite operation of addition, which is subtraction. So in order to eliminate the 6, we want to subtract 6, not just from one side, but from both sides. Eliminating it from both sides will allow us to maintain our equality. So here we go. Again, I'm going to start off by copying down exactly what we have written. 63 equals 6 plus x. And now I'm going to include whatever it is that we're going to subtract. In this case, 6. And again, not from one side, but from both sides. And now the motivation behind this is, now we are able to have the positive 6 minus a 6 simplified down to leave us with just a 6 on the right hand side. And now the only left thing to do is subtract 6 from 36. Let's go ahead and do that off to the side. 63 minus 6. So what we want to do is we want to do 3 minus 6. Since 3 is less than 6, we cannot do the subtraction, so we're going to have to borrow from the 6 next door. This 6 becomes a 5, and now our 3 becomes a 13. So now we're going to be doing 13 minus 6, and that's going to give us a 7. And then we just bring down the 5, so we're left with 57. So now we have 57 is equal to 63 minus 6. Now go ahead and do that in blue since our variables are represented in the color blue. So let's go ahead and state our conclusion. So let's see. What's the best way to say this? Well, the question says how many candies are not lollipops. So let's go ahead and state it. There are 57 candies that are not lollipops. And I'm going to do you one better. Again, I'm going to change this into red just to highlight the fact that we're maintaining consistency throughout the entire problem. So here we go. So again, the question asked, how many candies are not lollipops? And our response is, there are 57 candies that are not lollipops. So here we go. Now to make sure that our solution is correct, let's go ahead and check the result. Just like in step 4, we always want to start off with the original equation. The original equation was that found in step 3, so that's going to be 63 equals 6 plus x. The only difference now is that we know what x is actually equal to. So we have 63 is equal to 6 plus x, which we just found to be equal to 57. So here we go. On the left hand side of the equal sign, there's nothing left to simplify, so we're just going to bring down that 63. And now on the right hand side, we have to add up 6 and 57. So we'll do that off to the side as scratch work. So 57 plus 6. So let's see, 7 plus 6 is equal to 13. We bring down 3, kick up the 1. So now we have 1 plus 5 is 63. So 6 plus 57 is 63. Is that true? Is 63 equal to 63? It most certainly is. Therefore, our solution is correct.